In this video, we're going to look at two examples using sigma notation. This is important notation that comes up in multiple areas of math. The uppercase Greek letter sigma looks like this, and it always means the same thing. It always means we're summing something up. So in this first problem, this symbol, when we look at this, tells us we're going to be adding something up. And the thing we're going to be adding is this quantity here, negative 1 to the k plus 1 times k minus 1 to the third power. Above and below the sigma notation, we see k equals 0 and 3. This tells us three things. First of all, this tells us k is our variable. So k is going from 0 to 3. So when we add up this expression, k is going to have different values. It's going to start with 0, it's going to end with 3. And whenever you see this sigma notation, it's always understood that the variable increments by 1. So we're going to start with k equals 0. We're going to evaluate this expression in yellow. And then we're going to go to k equals 1, evaluate it again, k equals 2, k equals 3. So we're going to evaluate this 4 times in all. And then after we evaluate each one of these expressions, we're going to sum them up. We're going to add up these 4 things afterwards to see what this equals. So first of all, when k equals 0, when I put 0 in for k, we have negative 1 to the k plus 1. Well, if k is 0, that's just negative 1 to the 1. And if k is 1, the second parentheses, k minus 1, that's negative 1 to the 3. And so we have to be careful with our plus and minus signs here, but this is negative 1 times negative 1. They both have odd exponents, which equals positive 1. Moving on to k equals 1. If I plug in 1 for k, I'll get negative 1 to the second power. 1 minus 1 is 0. 0 to the third power, that one's just going to be 0. Moving on to k equals 2. Negative 1, if I plug in 2 for k, that's negative 1 to the third power. That's negative 1 because of the odd exponent. If I plug in 2 for k into this second parentheses, I get 2 minus 1, which is 1 to the third power. So negative 1 times 1, this is negative 1. And then lastly, if k equals 3, I plug in 3 for k. If k equals 3, k plus 1 is 4, and k minus 1 is 3 minus 1, which is 2, to the 8th. Now, negative 1 to the 4th is positive 1, because that's an even exponent. 2, I wrote that wrong. I was getting ahead of myself. I'm just reading off this formula verbatim. And when k equals 3, I have negative 1 to the k plus 1, which is 4. K minus 1 is 2, but that 3 is still 3. And then 2 to the third power is 8. So I plug in these different values of k, starting with k equals 0, stepping by 1 all the way up to the top number, which is 3. And then what the summation notation means is we sum these up. We're going to add these together. 1 plus 0 plus negative 1 plus 8. This all equals 8. So this summation equals the number 8. Now I said, let's look at one other example very briefly. Suppose we have something like this. I'm going to do the summation as k goes from, let's say it goes from 1 to 20 this time. And suppose we're adding up just 4. So this looks a little different than the previous example, because what we want to do is look at our expression and plug in k equals 1, then plug in k equals 2, and so on, all the way up to k equals 20. But there's no place to plug it in. Here, the function that we're working with is a constant. It's 4. So what happens in this example is really a little more straightforward. When I plug in 1 for k, I get 4. When I plug in 2 for k, I also get 4. So I'm going to have 4 plus 4 plus 4 plus 4 for each one of these values from 1 to 20. This is going to be 4 plus 4 plus 4 20 times. This is going to equal 80.